Hello, everyone. I hope everyone is doing good. In part 2 of derivative chapters, we were going to talk about the basic derivative rules. Actually, we cover all the derivative rules here with some examples, and also we provide the proof for some of the formulas. We start with the constant rule, which is used for all the constant functions. So for example, when you have y equals a and a is any real number, so y equals a is a constant function. I'm using the formula of a derivative for proving the derivative of the constant function. F prime of x here equals the limit of f of x plus h. So since this is a, so it is independent of any variable. So we're going to have a minus another a and divides by h. And h is going to 0. So this will be the limit of 0 over h. Okay, so because the top is 0, so 0 over a number that is going to 0, so it's going to be the absolute 0. So this means if you have any number or any constant function, like for example, y equals -3, the derivative for this function, y prime or f prime of x equals 0. For example, you have y equals 1 over 2. So what is the derivative of this constant function? Is going to be 0. The second formula is the power rule. And to me, this is one of the main formulas that is used in a derivative. The formula is about y equals x to the power of n. And n is not just a natural number, it can be the integer number, or even it can be the rational number. So means n can be a rational number like 1 over 3, 1 over 4, like that. So I say the derivative of this function is going to be n x to the power of n minus 1. And I'm going to prove this, but let's use some examples to show you how it works. For example, when you have y equals x to the power of 3. So the derivative here is going to be 3x to the power of 3 minus 1, which is x squared. Or even when you have, for example, radical x. Let's try this. Radical x or square root x is going to be x to the power of 1 over 2. We are using this formula that when you have the root n of x to the power m, you can write this term as a x to the power of m over n. So this is the formula that can be used when you're dealing with the radicals. So now we have x to the power of 1 over 2, which is the rational exponent. So now we use the formula, and it's going to be 1 over 2 x to the power of 1 over 2 minus 1, which is 1 over 2 x to the power of negative 1 over 2. And if we want to make the exponent positive, you can just simply move it to the bottom to make the exponent positive and just convert to the radical as the original format. So the answer will be 1 over 2 root x. That's it. So now we're gonna prove this formula, and I'm using the same F prime formula to prove this. First of all, what I need is the limit of, okay, so x plus h to the power of n minus x to the power of n divides by h. But you should know how to expand this function in the top, the x plus h to the power of n. So I'm trying to expand this and then subbing in the limit. So x plus h to the power of n minus x plus n. This will be, okay, x to the power of n plus n, x to the power of n minus 1h, and then plus n times n minus 1 over 2 x to the power of n minus 2 h squared, and then plus h to the power of n. This is the expansion of the first part minus x to the power of n. And if you are interested to know how we found this expansion here, so you can just refer to the formula that is the combination of the variables and the coefficients that you can make here. So it's gonna be x to the power of n plus the combination of actually 1 out of n, x to the power of n minus 1, and then h. So means in each step, we reduce one exponent from x and we add one exponent to h, and then plus 2 out of n, x to the power of n minus 2, h to the power of 2. And you keep continuing this to have the combination of n out of n, which is going to be 1. And then there is no x here. At the end, it's going to be x to the power of 0, and then h to the power of n. So this is the expansion formula that can be used here. And when you sub in the numerator of the limit, so we're going to cancel x to the power of n by negative x to the power of n, these terms. And then you're gonna have n x to the power of n minus 1 times h plus the rest. Divides by 2, h squared, and h to the power of n. So now if you sub in this formula, this revised formula, let me call it number 1. Then in the F prime formula in the top, we just sub in this, and then also we can factor from h as well. So if we factor from h in the top, so we have n, x to the power n minus 1 plus n times n minus 1 divides by 2, x to the power of n minus 2 h, and then to the end, which is h to the power of n minus 1. And then they are all over h. Don't forget to add limit here, and when h is approaching to 0. So h is the common factor that can be canceled from the top and bottom. What you're gonna get the limit of n x to the power of n minus 1, which is independent from the variable h here. and plus the rest of the term that they all have at least one h. So means, let me just call it, the terms with h, okay, which starts from here to the end. So means this is called terms with h. When you sub in h, and h is the term that is multiplied in the second part, so this part will be 0, and nx to the power of n minus 1 is not dependent on h, so you can factor it out, and then plus 0. So the answer is nx to the power of n. So that's the proof of the formula, and this is one of the user-friendly formulas that can be used in derivative, and also it can make some fractions or the square roots, very easy when you're converting the exponent to when you're converting the radical to the rational exponent, or when you have the fraction and you convert this to the negative exponent. So let me just use an example here. Y prime is going to be nx to the power of n minus 1. For example, we have the square root of x plus 1. And also y equals 1 over x to the power of 3. For the first part, we have x plus 1 to the power of 1 over 2. And the second example is x to the power of negative 3. So we're using the same formula. So y prime will be 1 over 2 x plus 1 to the power of 1 over 2 minus 1. Of course, because here we have x plus 1, so we should multiply by the derivative of the bracket in the bracket as well, so which is going to be 1. So we'll explain this in the chain rule. And also for b, y prime will be negative 3 x to the power of negative 4. And then if you just move it to the denominator, the exponent will be positive. That's the application of this formula and how it can be useful for you when you're working with the power rule. The next formula that is used here is y equals a f of x. Means when the function is multiplied by a coefficient, then you can factor the coefficient first, and then you multiply by the derivative of the function. That's simple. So, for example, you have 2x to the power of 5. 2 is the coefficient. What is y prime? Y prime is 2, and then you take the derivative of x to the 5. So it's going to be 2 times 5x to the power of 4. Or, for example, we have y equals 3 over x cubed. So we can write this as a 3x to the power of negative 3. And how do you find y prime? Y prime will be 3, and then you take the derivative of this term. So it's going to be 3 times negative 3, x to the power of negative 3 minus 1 will be negative 4. So it's going to be negative 9, x to the power of negative 4, and then you can just simply write it as the negative 9 over x to the power of 4 to make the exponent positive. The next formula will be the sum rule. For example, when you have h of x equals the sum of two functions, what is h prime? H prime is the sum of the first function, is the derivative of the first function plus the derivative of the second function. When we say sum, means the algebraic addition, so it can be addition or subtraction. So as an example here, h of x equals 3x squared plus radical x. So I'm going to write h of x as 3x squared plus x to the power of 1 over 2. Just converted the square root to the rational exponent to use the power rule. Now h prime will be the derivative of the first term plus the derivative of the second term. And now for each function, you can apply the power rule. So you can factor from the coefficient here, and then the derivative of x squared will be 2x, and then plus 1 over 2 using the power rule. X to the power of 1 over 2 minus 1, which is negative 1 over 2. So this will be 6x plus 1 over 2 times 1 over root x. And then you can take the common denominator here. So this will be 12 x to the power of 3 over 2 plus 1. So means when you have the addition or subtraction of two functions, you can take the derivative of each function separately, and then you add the final answers. Number 5 is about the product rule. H of x equals f of x times g of x. So what is h prime? So h prime is f prime times g, and then plus f of x times g prime. See this combination? F prime, the derivative of the first function times the second function plus the derivative of the second function times the first function. And how we can prove this formula? Using the basic principal derivative formula. So we're using that limit and we can prove this. Now, let's use some examples here. For example, y equals x squared multiplies by x plus 1. We're using the product rule, so h prime will be the derivative of the first function. So the first function is x squared here, so we can take x squared as f of x and the bracket as g of x. So h prime is the derivative of the first function, 2x times the second function plus the first function times the derivative of g, which is 1. So the derivative of x is 1 and derivative of 1 is 0. And now simplify it. So 2x squared plus 2x plus x squared. So it's going to be 3x squared plus 2x. That's about product rule. The next formula is the quotient rule. And h equals f over g. Of course, here there are some restrictions, so g of x can't be 0. So we assume that we have all the proper conditions here. Now, what is the formula for derivative of this quotient? So h prime equal derivative of the top times the bottom minus derivative of bottom times f all over gx to the power of 2. Let's try. So h of x equals 2x over x plus x squared minus 1. Then h prime will be the derivative of the top. So derivative of 2x will be 2 times the bottom minus f of x multiplies by the derivative of g, which is 2x, and then divides by g to the power of 2. So this will be 2x squared minus 2 minus 4x squared in the top, and then divides x squared minus 1 to the power of 2. So this will be negative 2x squared minus 2 all over x squared minus 1 to the power of 2. And that's about the quotient rule. 6 formulas so far. We have one more formula, which is called the chain rule. And I'm gonna show you the chain rule in different ways. Assume that we have the combination of two functions, so f, o, g of x. I hope you know what is the meaning of f, o, g. So it is f of g of x. Let me use an example. When you have y equals root x plus 1, we can say this is a combination of two functions. And how? So if you take f of x as the square root of x and g of x as a linear function. So then you find f o g of x. This means f of g of x, which is f of x plus 1. So means the function f, which is the square root of x, with the new variable is going to be the square root of x plus 1. So now the derivative of this function, the combination of f o g, will be f prime of g of x multiplies by g prime. And how we can show this? Let me just use this example to take the derivative. So we assume that y is a square root of x plus 1. How we can take the derivative? So y prime is gonna be f prime of g of x. So f is root square, is root x, square root of x. So means it is x to the power of 1 over 2. So the derivative of f will be 1 over 2. And then g of x, which is x plus 1 to the power of 1 over 2 minus 1. This is f prime of g of x. And then it is multiplied by g prime. What is g prime? Is 1 plus 0. So y prime here is 1 over 2 And 1 over root x plus 1 multiplies by 1. So it's going to be 1 over 2 root x plus 1. The second way that is mostly used for power functions, when you have this combination, y equals u to the n, and u is another function. So means here you have g of x, which is a new function, and then to the power of n. So means it is still FOG, the combination of two functions. And how we can take the derivative of this function, it is the same as the power rule. So it's going to be n, u to the power of n minus 1. But because u is another function, you should multiply by the derivative of u as well. Let's use some examples. We have y equals x squared minus 5x plus 2, and then to the power of 3. So now what is u? U is what you see in the bracket. Y prime will be, we're using the power rule, so means it's gonna be 3, and then to the power of, and then u to the power of 2. So x squared minus 5x plus 2 to the power of 2. And then you should multiply by u prime as well, so which is 2x minus 5. So this part is n, u to the power of n minus 1, and then it is multiplied by u prime. We also can use it for another examples that are having the radicals. For example, we have a square root of 3x squared minus 1. So first of all, you can convert the radical to the rational exponent. So it's going to be 3x squared minus 1 to the power of 1 over 2. And then using the same formula. So y prime will be, so what is u here? U is 3x squared minus 1. So we're using the formula is going to be 1 over 2, 3x squared minus 1 to the power of 1 minus 1 over 2, which is negative 1 over 2. And then it is multiplied by u prime. So and what is u prime? The derivative of 3x squared will be 6x minus 0. 1 is the constant number, so derivative of the number will be 0. And then you can cancel 6 by 2. So you're going to have 3x in the top divides by the square root of 3x squared minus 1. And this is the way how we use the chain rule, especially in B, when you have the power rule, but it's in the combination of two functions. So it's going to make the chain rule very, very easy using the formula. And then you just multiply the power rule by u prime, the derivative of whatever you have in the bracket. So in this video, we covered all the basic derivative rules. I hope this will be useful for you, and see you in the next video. Thanks.